July 1944, Normandy. A 30-ton Sherman tank grinds to a halt before an impassable wall of earth and tangled roots. The driver guns the engine, steel tracks clawing for purchase as the machine rears up, attempting to climb the ancient hedgerow. For one fatal moment, it hangs suspended, its thin underbelly armor exposed to the fields beyond. From the shadows, a German anti-tank gun fires a single, precise shot. The Sherman erupts in a column of fire and smoke. This wasn't a freak accident. This was the routine. A crisis repeating itself dozens of times a day, bringing the Allied advance to a dead stop. The Normandy breakout was on the verge of collapse, threatening a war of attrition the Allies could not win. The answer wouldn't come from high command, but from the mud and frustration of the front lines. It was a crude, improvised weapon, steel tusks welded to a tank, designed to tear through the very earth that was trapping an army. But could one simple invention truly be the key to victory? Or does the legend of the Rhino hide a more complicated truth? The problem wasn't the German army alone, it was the land itself. The Norman countryside was a fortress not of concrete, but of earth. For 1,000 years, farmers had marked their fields by building up massive earthen walls, or levées de terre. To the Americans, they were just hedgerows, a fatally misleading term. These were not garden hedges. They were ancient ramparts, 10 to 15 feet high, packed as hard as stone, and interwoven with the gnarled roots of trees and thorny bushes. They formed a suffocating labyrinth of small, sunken fields, each one a natural fortification. American armored doctrine, designed for fast, sweeping advances across open country, was completely paralyzed. When a Sherman tank tried to drive over a hedgerow, its thin underbelly armor was lifted into the air, presenting a perfect, stationary target for German anti-tank guns and Panzerfaust teams hidden in the next field. The result was a predictable, fiery brew-up. The alternative was for combat engineers to crawl forward under fire, plant explosive charges, and blow a gap. But this was slow, dangerous work that announced their exact position to every German mortar and machine gun in the area. Worse, a successful blast created a single, obvious bottleneck, a perfect kill zone that the defenders could zero in on. By July 1944, the advance had slowed to a crawl, measured in yards per day, with casualties mounting at an unsustainable rate. The generals at SHAEF headquarters had no answer. If a solution existed, it would not be found on a map in a London planning room. It would have to come from the mud and steel of Normandy itself. Among the men trapped in this bloody stalemate was Sergeant Curtis G. Culin of the 102nd Cavalry Reconnaissance Squadron. Day after day, he watched the same fatal sequence unfold. Tanks rearing up, exposing their bellies, and burning. But Culin, a former welder from New Jersey, saw what the tacticians had missed. The problem wasn't a lack of engine power, it was the wrong application of force. He realized the tanks were trying to go over the hedgerows when they needed to go through them. The inspiration, according to his later accounts, came from watching an engineer's bulldozer clear a path. He sketched a simple, almost brutal idea. A set of sharp steel tusks welded to the front of a Sherman. They wouldn't lift the tank. They would attack the hedgerow's base, ripping into the packed earth and roots, tearing the obstacle apart from the ground up. It was a brilliant concept, but for a sergeant on the front line, it was just a drawing on scrap paper. To make it real, he'd need steel, welders, and, most difficult of all, the attention of a general. Cullen's idea was one thing, steel was another. In the chaos of the Normandy front, raw materials weren't simply handed out for an NCO's experimental project, but the solution was lying right under their noses, rusting on the very beaches they had just fought to capture. The sands were still choked with thousands of tons of German anti-tank obstacles, massive crisscrossing steel beams known as Czech hedgehogs. They were part of Rommel's Atlantic Wall, designed to gut landing craft and stop tanks cold. Now, in a twist of profound irony, combat engineers began dragging these symbols of German defense from the surf, cutting them apart with torches and trucking the steel inland. The enemy's shield was about to be forged into a sword. Working under the direction of Cullen's superiors in the 2nd Armored Division, a maintenance crew under Lieutenant Charles K. Haywood got to work. They first welded a crude, tusk-like assembly onto the front of a light M5 Stuart tank. It charged a hedgerow, the steel teeth bit into the earth, and the tank tore straight through. The concept was proven. Now for the real test. A heavier version was fabricated and welded to the hull of a Sherman. On July 14th, a demonstration was arranged for the commander of the 1st U.S. Army, Lieutenant General Omar Bradley. Bradley arrived, deeply concerned by the stalemate and skeptical of any miracle cures. He watched as the modified Sherman approached a thick, ancient hedgerow, the kind that had been a death sentence for weeks. The tank didn't try to climb. It lowered its head, the engine roared, and with a sound of ripping earth and snapping roots, it burst through to the other side, its main gun still level and ready to fire. Bradley was stunned. He immediately turned to his aide. His orders were swift and absolute. This wasn't a recommendation to be studied. It was a command that electrified the entire rear echelon. Bradley wanted this device, now codenamed Rhino, on as many tanks as possible, and he wanted it yesterday. A frantic Army-wide crash program began. A directive, dubbed the Steel Program, gave the project top priority for all welding equipment and personnel. Specialist welders were pulled from artillery repair, from truck maintenance, from every corner of the Army. Field depots were transformed into roaring 24-hour factories, working under camouflage nets to mass-produce the cutters from the harvested German steel. Within a week, hundreds of welding teams were working simultaneously, fitting the Rhinos to Shermans, Stuarts, and tank destroyers of the First Army. The goal was to equip at least 60% of the tanks before the launch of the summer offensive. It was a monumental feat of battlefield improvisation. On the other side of the hedgerows, German anti-tank gunners had grown confident, almost complacent. The bocage was their greatest asset. They knew the Americans had to use the gates or blow a gap, and their guns were pre-sighted on these fatal funnels. But in mid-July, their commanders began receiving confusing reports. An American tank had just appeared from a solid wall of earth, then another, then a whole platoon. The reports were first dismissed as battlefield exaggerations, but soon the pattern was undeniable. The kill zones the Germans had so painstakingly prepared were being bypassed. The predictable, channelized American attacks were suddenly becoming unpredictable, multi-pronged assaults. The foundation of their defensive strategy, which relied on the terrain forcing the enemy into their gun sights, was beginning to crumble. Confusion was turning to alarm. By the third week of July, workshops were churning out hundreds of Rhino devices. The tool, born from one sergeant's frustration, was now an instrument of Army policy. But a tool is useless without a plan to wield it, and the High Command was about to combine this simple invention with a strategy of terrifying and unprecedented force. But the legend of the lone inventor simplifies the reality of war. Sergeant Culin wasn't alone. In the 2nd Armored Division, a technician 5th grade named Robert E. Weiss had independently developed a similar saw-toothed cutter. It was a case of convergent evolution, born from a shared, desperate need. Crucially, the Rhino was only one piece of a much larger, far more violent plan. Operation Cobra. General Bradley's strategy was to use the tanks not to grind, but to exploit a hole created by a terrifying new tactic. 1,500 heavy bombers laying a carpet of explosives on the German front line just before the assault. The plan was set. The tanks had their teeth, but no one knew if the GIs could survive the friendly fire to even begin their attack. At 09:38 on the morning of July 25th, the ground in Normandy began to shake. A deafening roar filled the sky as nearly 3,000 Allied bombers passed overhead, unleashing a torrent of high explosives onto a narrow strip of the German front. For over an hour, the world was reduced to thunder, dust, and smoke. Then, an eerie silence. And then, the order to advance. Hundreds of Sherman tanks, their new steel tusks glinting, surged forward. They did not slow at the hedgerows. They did not search for gaps. They tore their own paths, hundreds of them, ripping through the ancient earthen walls. For the German defenders who survived the bombing, the nightmare was just beginning. The static defensive web, held for 7 weeks, didn't just bend, it disintegrated. Tanks and infantry were pouring through the landscape from every direction at once. In a matter of hours, the front line simply ceased to exist. The path out of Normandy was finally open. We began with the image of one tank hung helpless on a wall of earth, a symbol of an army trapped. But Operation Cobra ended with hundreds of tanks advancing on a broad front, masters of a terrain that had once been their prison. The Rhino hadn't made the Sherman invincible. It added no armor, no bigger gun. It did something more fundamental. It restored mobility. It allowed the entire Allied doctrine of overwhelming force and maneuver to finally be unleashed in a landscape that had denied it. It was the crucial, low-tech key that unlocked a high-tech victory. The breakout from Normandy was finally achieved by turning the enemy's own steel obstacles into the very teeth that devoured their fortress of earth.